Okay, so this is our chemistry part 2 unit. We're going to be learning about mixtures and solutions. Okay, so our first target is target 29. We're going to classify matter as a mixture or a compound. So we've already in target 14 talked about the differences between a mixture and a compound. So what we're going to do in this target for 29 is we're going to go into a little bit more detail about the different types of mixtures and how they're different from a compound. Okay, so what you're going to do is you're going to create, instead of doing Cornell notes, you're going to just create a double bubble map. Okay, you want to use 3 colors, okay, just like I've been using, or that you see here, and one, I don't know why this is twice, but you're going to put mixtures, the other one is compounds. Okay, remember the circles in the center are the ones that mixtures and compounds have in common, and the ones that are on the outside with each big circle is how they're different. Okay, so we're just going to go over and review how mixtures and compounds are alike and how they're different. Okay, so this does not go there. All right, so let's first talk about how they are alike. Okay, remember, both mixtures and compounds are a combination of 2 or more substances. Okay, now how those substances are combined is what makes them different, but they are made up of at least 2 or more substances. Okay, compounds, remember, are made up of 2 or more elements that are chemically combined. Mixtures are made up of 2 or more substances which are not chemically combined. Here's the other one. Okay, so now let's take a look at mixtures and how they're different from compounds. Remember, mixtures are not chemically combined. That means that they keep their own identity. So whatever's in a mixture can keep the same properties that they've always had. Okay, so if you have a bag of Skittles and you have all the different colors of Skittles that have different tastes, if you pull out a red Skittle, it's not going to taste like a green Skittle because it's next to the green Skittle. It's still going to taste like a red Skittle. It still keeps its identity. I believe I spelled identity wrong. I did. I can't change it, but that's spelled wrong. Okay, let's see what else we've got. Remember, mixtures can be separated by physical means. So you can separate a mixture. You can sometimes heat it up and evaporate. Okay, just like salt water, you can evaporate the water and leave the salt behind. Sometimes you can physically actually separate with a bag of Skittles. You can separate them physically by color. Okay, there's a lot of ways that you can separate mixtures physically, and that's a big difference between compounds. In mixtures, proportions can be changed. So for example, lemonade is a mixture. Some of you like to add a lot of sugar to your lemonade, so you like a strong lemonade mixture or solution. Some of you might not like a lot of sugar in your lemonade, so you like a smaller amount, so it's not as strong. It's a weaker lemonade solution. So mixtures, the proportions are not fixed. You can change them up depending on what you like. Same thing with hot chocolate. I know I add 2 bags of the hot chocolate mix to a cup of water. That's what I like. I like a really strong hot chocolate. Some of you might only add 1 bag. So mixtures, the proportions can be changed. Okay, and then the differences with compounds. Compounds are chemically combined. And the difference between physically and chemically combined usually means that the elements have to have a lot of energy and they form a very strong bond between the 2 elements that are combined. That's what chemically combined means. Which also means that there are exact proportions. For example, water is a compound. Water is always going to be H2O, meaning 2 atoms of hydrogen will always bond with 1 atom of oxygen. They will always be in that exact proportion. If you have something else, if it's H2O2, that's not water, that's hydrogen peroxide. So compounds will have exact proportions, unlike mixtures that will not. Compounds will also create a new identity. We talked about this in Target 14 with the example of sodium and chlorine. Sodium and chlorine are both elements. They are both poisonous. But when you chemically combine sodium and chlorine, they make table salt, which is not poisonous. So when you chemically combine elements, they get new properties or a new identity. I spelled identity right on that one. Compounds can be separated by chemical means. So there's a difference between physical and chemical means. Chemical means you need to add a lot more energy to separate the compounds. For example, water, which is a compound, you can't separate it physically. If I pour water into two different glasses, it's still water. You did not separate the compound. But if I apply electricity to water, I can actually separate, I can break those bonds between the hydrogen and oxygen atoms, and I can separate, through the electricity, I can separate the compound into hydrogen and oxygen gas. That's what I mean by chemical means. It takes a lot more energy to separate compounds and break those bonds that were formed between the elements than it does physically separating. So I think that was one of the things that was supposed to be on like that for some reason is not showing up. But let's go ahead and put it in there. Ooh, that's going to be way too big. Let me pause this. So one thing both mixtures and compounds have is they're both made up of matter. Okay? Remember, mixtures can be a mixture of just different types of elements. Mixtures could be a different types of compounds. Mixtures could be made up of elements and compounds. Compounds are only made up of elements. Okay, so they're all matter. Okay, so let's do a quick review down below. Okay, so remember, okay, an element is one pure substance that's only made up of one type of atom. Remember, elements are determined by the number of protons that that element has. Okay, for example, calcium always has 20 protons. So if you are looking at matter and you see 20 protons, you know you have a calcium atom, and that's that element. If we look over here at a compound, compound is made up of two different elements that are chemically combined. That's what that line means. There's a bond between them. There's an attraction that can only be broken by an extreme amount of energy. Okay? And you cannot separate an element and a compound. That's why they're pure substances. Okay? We cannot separate this compound without an extreme amount of energy to break those bonds. Then we've got a mixture. If you notice, we've got a mixture that contains a compound. The triangles and circles are elements. And then the blue rectangles combined with the red oval, that's a compound, along with the green square and the pink octagon, that's chemically combined, that's a compound. So a mixture can be a mixture of elements and compounds. And if you look here, you can separate this mixture. I can pull out the triangles from the circles. I can pull the different compounds. I can separate those. And that's why a mixture is different. It's not a pure substance because it can be separated. Okay, so some common chemical compounds: water, H2O. Okay, fixed proportions: 2 atoms of hydrogen, 1 atom of oxygen. Ammonia, 1 atom of nitrogen bonds with 3 atoms of hydrogen. That's fixed proportions. Carbon dioxide, 1 atom of carbon, 2 atoms of oxygen. Hydrogen peroxide, 2 hydrogens, 2 oxygens. These are fixed proportions. They will always bond this way to make that compound. Okay, let's do some more review. Okay, this picture. Okay, take a look at it. The first thing you should ask yourself is, can it be separated by physical means? And if you take a look, this trail mix, you can separate out the peanuts and the raisins and the M&Ms. And the different types of nuts. So this is a mixture because it can be separated. Okay, KoolAid. Okay, KoolAid, if I heat KoolAid up, the water will evaporate and leave behind the sugar. So KoolAid can be separated, so it is also a mixture. Okay, sodium chloride. If I take salt and I pour salt and try to separate it into its parts, I cannot do that physically. It's still salt, so it cannot be separated, so it's not a mixture. So that means it's either an element or a compound. So then we need to take a look and see, is it made up of one element or more than one element? As you can see, salt is made up of sodium and chlorine, two separate elements, so it's a compound. Pizza, okay, we look at it, can I separate this pizza out? Yes, I can. I can pull the pepperoni, the olives, I can separate the cheese, so this is a mixture. Okay, two hydrogens and oxygens. Okay, that is actually going to be water. I cannot separate water. It's made up of two elements, so that is a compound. A bouquet of flowers. I can separate the flowers out from the red, from the purple, from the different yellows, and that is a mixture. Ammonia. It's made up of nitrogen and 3 atoms of hydrogen. That's two different elements chemically combined, so that's a compound. Okay, one of the big differences between mixtures and compounds is, like I mentioned earlier, is that they can be separated. So we're going to actually do different labs where you perform ways of separating mixtures. And you're going to do a lot of practice with this. If you want to write down what I'm saying in your notes, if you feel like you're going to forget the ways that you can separate, you may do that. Okay, one of the ways to separate mixtures is through chromatography, which I'll get to in a minute. But the most common ways that you guys know of is evaporation and filtration. Okay, there are other ones called distillation, but we get into that a little bit more in 7th grade. Evaporation, we know, is just basically heating up a liquid and separating the parts out. Filtration is when you strain something. So if we have a mixture of sand, gravel, dirt, and rocks, we would put it through a strainer and let the smaller particles flow through and separate them out by sizes. One of the big ways that we separate mixtures is through chromatography, specifically ink. We talked about this a little bit in Target 14. Ink is a mixture of different colors. Chromatography is one of the ways that you can separate out ink. If you take a look at chromatography, basically you have a piece of paper that has an ink color on it. You can do that with a pen, okay? And what you do is you put that sheet of paper into water. Water is what we call solvent. It will dissolve things, and the solute is ink. And as water goes up that paper, it will actually break that ink out into its colors. Okay, so you can see that picture here. This black ink dot got separated out into the colors that make up that black ink into yellow, pink, and blue, or red, not pink. This is what it looks like when you actually do that. And we will do an experiment showing you this. Okay, uses of chromatography. Okay, we use this when we're looking at metals and organic compounds in solutions. Okay, we use it, and that would be liquid chromatography. We use gas chromatography to separate out gases. That helps us detect bombs in airports and identify drugs that are used. It also helps us in forensics to help find, when we look at fibers that are found on a victim, we can separate those fibers out and see what they're made of. Okay, like I said, we use it to look at gases. Okay, we also use chromatography to separate out liquids in pesticides and insecticides. We use it with dyes or inks. And then paper chromatography, like what I was showing you previously with the inks, we use that with fingerprinting. So we look at our fingerprints and we can separate the fingerprint ink out. And we use it in testing antibiotics, which help you find, it's a chemical that you're used to cure a disease or help you get over a disease. So those are just some uses of separating mixtures and how we do that. Okay, so hopefully after this, Target 29, we've reviewed what a mixture, the differences between a mixture and a compound, and presented some ways that we're going to be separating our mixtures to show how they're different from a compound.